Here's our first free response question. We have a particle moving along a straight line for an interval between 0 and 5. The velocity is given by v of t equals -2 plus t squared plus 3t to the 6/5 power minus t cubed. The position is given by s of t. It's known that s of 0 is equal to 10, so we're being told that this starts out at a position of 10. We want to find all the values in the interval for which the speed is 2. All right, so in this question, if the speed is going to be 2, remember that speed is always positive, so this means that we could be looking at either a velocity of 2 or -2. Okay, that's really what we're trying to figure out here. So honestly, I would probably just take that equation. That equation is -2 plus t squared plus 3t to the 6/5 power minus t cubed. I would actually just set that equal to 2. And I would set the equation equal to -2. And again, this is the calculator part of the test. You can solve this on your graphing calculator. By the way, the other way to do this is to say you want the absolute value of this to be equal to 2. So you could put absolute value bars around that whole thing and just set it equal to 2. But I'm going to do it this way. So a few different ways you can do this. You can use the 0 function on your calculator. You could subtract 2 from both sides and you can get it equal to 0. But anyway, so I've typed this into my calculator here. You can see I've typed the equation in there. And again, they are fine with you using your calculator to solve these things. So I want to know where this function is equal to 2. So I'm going to graph the equation. By the way, if we look at this, I just kept the standard graph here. We're only supposed to look at the interval between 0 and 5, so we're only looking at this period here. But anyway, I want to figure out where this function's equal to 2 and where it's equal to -2. And so really easy way to do this. You could just graph y equals 2, and you could find the intersection point with y equals 2. So I'm going to go back and graph that. There we go. There's where it crosses 2. Remember, we're only looking between 0 and 5. And remember, you can hit the calc button there on your calculator. It allows you to calculate zeros or intersection points. So hit second calc, and we can find an intersection point there, choice 5. And so let's see, we can scroll up here, pick a point on the first curve and a point on the second curve, and hit enter on the guess. And it tells us that t is approximately, what is that, 0.944. You can round to 3 decimal places, seconds. Okay, and that's between 0 and 5, so that's one place. Okay, now there's this other point over here, so I want to see where that is. So I'm going to hit second calc again, go back to the intersect, and I'm going to go over here to that second point and scroll to that second point. Are we still within an x value of 5? Yeah, we are. And then go on the other curve and hit enter on the guess. And we're getting t is approximately 3.128 seconds. But remember, the time could also be -2. The velocity could be -2. So I'm going to go back to y equals, and I'm going to graph y equals -2 and see where it crosses that. And again, we can see this coming up here on the graph. And there's y equals -2. And I think it's just barely missing below here. You may want to check that, but I'm going to check this other point over here. So anyway, I'll hit second calc, and I'll go to that intersection point, and go over here to that point. Anyway, I'm on one curve, I'll hit enter. On the other curve, I'll hit enter again, and it looks like we're getting a time of about 3.473. Okay, so those appear to be my times. And again, as far as work goes, they just need to see what your equation is. Okay, if you're on the calculator part, they don't actually have to see what your solution is. So you probably want to say something like the velocity, or I'm sorry, the speed is 2 when t equals 0.944, t equals 3.128, and t equals 3.473. And I don't remember what the units are. You really should put units on there as well. 2b, it says, write an expression involving an integral that gives the position s of t. Use this expression to find the position of the particle when t is equal to 5. Well, notice up here they tell us the position when time is 0, okay? And I don't know about you, but this looks like a really tough problem. You know, normally you would integrate the velocity. They take the derivative of the position equation to get the velocity. You would take the integral to get the position equation. But that inside function there is going to be too hard to integrate, and you have a calculator. So this is what I was talking about on the earlier video. You should be able to take a definite integral from your starting point to your ending point, and that integral will tell you what your displacement was, how far you moved in that time interval. Now the interesting thing is they don't need the they just want an expression with an integral. So here's what's going to happen. Okay, remember they told us that s of 0 is equal to 10. So it's starting out at a position of 10, okay, not at a position of 0. Okay, so we're starting out at 10, and we just need to add the displacement. The displacement's just going to be the integral of the velocity function from 0 to whatever the time is that we end up. So let's say we say from 0 to t of my velocity function. By the way, you should probably use some other variable for your velocity. Actually, let's call this, let's go back here and look, actually. They say write, yeah, okay, an integral expression for s of t. So yeah, the input variable should be t. So we're going to go from 0 to whatever the time is of the velocity. Technically, you want to use some other variable, maybe call that like v of x or something like that. So the starting position plus the integral of the velocity function. And this is a function, we're inputting the time as one of the bounds. So I want to find the integral between time equals 0 and time equals 5 in the one that they wanted me to do. To actually find that. But this is the function that they want me to write. And so the point is, because they didn't specify a time for the first part, leave the time as just a variable, okay? But again, don't call this v of t because we're not inputting the time here and here. So use some other variable for that. But anyway, to actually evaluate it, they wanted us to find s of 5, okay? So we're going to start out at a position of 10, and we'll take the integral of the velocity from the starting time of 0 to the ending time of 5. And remember that velocity function was -2 plus t squared plus 3t to the 6/5 power minus t cubed. Okay, and you should just be able to put that in the calculator and get an answer here. So let's go ahead and try this. Anyway, I'm not sure anybody wants to see me type all this in, but I'm going to math 9. We're doing the integral from 0 to 5. Zero to 5 of -2 plus t squared plus 3t raised to the 6/5 power minus t cubed, and then technically dx in this case. Okay, so that's going to be my displacement when it gives me an answer there. Okay, and then we're adding 10 to that answer that we got there. And it looks like the position at time t equals 5 is going to be about -9.207. And they didn't have units here, so it looks like we're okay on that part. By the way, before we go on, I need to make a slight change in part A. I went back and looked at the question a little bit more carefully. They specified a time between they specified a time between, in the time interval between 2 and 4, okay? So this is not between 2 and 4, so, there were no units involved in the question, so that's all you would need. Anyway, part 2 looked good, I just checked that. Let's go on to part 3 now. Okay. So part 3 says find all times in the interval between 0 and 5 in which the particle changes direction, justify your answer. Okay, so remember the idea here is your velocity is positive. That means it's moving to the right. If the velocity is negative, it's moving to the left. So if it changes direction, it's got to go from positive to negative or negative to positive, which means it's got to pass through 0. Okay, so basically we want to figure out when the velocity is equal to 0. And you might as well write down that you want to find that. But anyway, we're going to take that equation and we're going to set it equal to 0. And the nice thing is you probably already have this in your calculator. And again, it's the calculator part. You don't have to show the algebra for that. So we're going to go to the calculator here. I've already got that function typed in. So we just want to figure out, I'm going to take out this other equation here, but we want to figure out when this function is equal to 0 in the interval between 0 and 5. And so we'll take a look. And you could change the window if you wanted to. Like if you wanted to only look at x values between 0 and 5, you could. Anyway, let's graph it. So we can see it's equal to 0 at that point right there. The velocity is equal to 0 at that point there. Now, just because the velocity is 0, you know, it could be going with a positive velocity, stop, and then go with a positive velocity again, and it doesn't change direction. But notice, we go from a negative velocity here to a positive velocity. And so when it passes through 0, it's going left for these negative velocities. It's going to the right for these positive velocities. Same thing here. Positive velocity is over here, and it switches to negative. So we just need to find out when those two velocities are 0. That's the only thing we're going to need to do here. And remember, your calculator has that 0 function. So again, they need to see that you're setting the velocity equation equal to 0. They don't care how you solve it because you've got a calculator. So second calc, the 0 function here, remember it has you pick a value to the left and a value to the right, and then you can just hit enter on the guess. And so I pick a value to the left, a left bound, pick a value to the right where it crosses 0, hit enter on the guess, and looks like it's giving us about 0.536. And the key here is, again, that the velocity changes from negative to positive at that point, okay? So I don't think you have to show anything for that, but you do want to say that the velocity changes from negative to positive at t equals 0.536. And then the other place where it happens, we can hit second calc, use the 0 function again. Again, pick a point to the left of where it crosses the axis, and pick a point to the right, and it should tell you exactly where it happens. So it's a little bit slow, but we're getting over there. Okay, so click to the left, go somewhere and click to the right, hit enter on the guess, and that's telling us that t is about 3.318. Remember that you want to round to at least 3 decimal places. So your justification would be something like at t equals 0.536, v of t changes from negative to positive at t equals 3.318, v of t changes from positive to negative, probably something like that. Okay, and we'll look at the scoring here in just a second. Okay, let's move on to part 4. Part 4 says, is the speed of the particle increasing or decreasing at t equals 4? Give a reason for your answer. Well, remember, speed increases or decreases. You've got to look at the velocity and you have to look at the acceleration. Okay, so you know what? Actually, if we go to the calculator here, we can find the velocity at 4, right? I'm out of space in my paper here, but we want to find v of 4 and we want to find a of 4. Those are the two things that we're trying to find here. V of 4, I already have the velocity equation in my calculator, so I'm just going to go to the table and go to 4 on the table, and we can see here the velocity is negative 11.48 and scroll over here, you can probably get more decimal, 0.476. Okay, but really the key is the velocity is negative, and the acceleration is the derivative of the velocity. I would probably just go back to your regular thing here. Remember, you can use Math 8 and find the derivative. And I might say something like v prime of 4 equals a of 4, like noting that you're taking the derivative of the velocity at 4. Again, that counts as showing work, though. And your function is negative 2 times the quantity x squared plus 3x, all taken to the 6/5 power minus x cubed. And we want to take the derivative when x is equal to 4, okay? And that's going to be also negative. It's about negative 99.409. By the way, I don't think you actually have to list those values. You just have to say v of 4 is negative and v prime, which is the same thing as a of 4, is negative. And because the velocity and acceleration are negative, it's going to be speeding up, okay, because they have the same sign. Let's go ahead and take a look at the answers here, and we'll kind of see how they write these up. Remember, these are 9 points, okay? And notice they don't do a ton of writing on these, okay? But the big thing here is you have to consider, for the first part, remember the speed was 2. So they look at the absolute value of the velocity. I'm sure if you considered velocity being 2 or negative 2, they would take that as well. And they have those 2 answers there. Remember, I had to throw one answer out, okay? And you have 2 out of 9 points if you get that, okay? But remember, if you don't show that first part, you don't get the point for the second part. You have to have the work there. You can't just slap an answer down and not make some kind of references where it comes from. Okay, part 2, we're taking our initial value, our initial position of 10. We're adding the displacement from 0 to some time. And notice they changed the variables there because we're not inputting the time for x and dx. We're just inputting the time. We want to take the integral from 0 to whatever time we want to end at. Okay, that's how you write an integral function. And then they, of course, sub the values in and they find the negative 9.20. So we're up to 4 points, which gets us to kind of a passing level here. Okay, part C, I think those were the 2 values I had. And notice just says the velocity changes sign from negative to positive at those times. And again, I think you should set the velocity equal to 0. Notice they do give you a point there for saying that you're setting the velocity equal to 0. And then you get 2 additional points for those explanations. Okay, so again, it's nice if you can kind of summarize it and kind of explain it like this, which is very good. Okay, part D, notice they just found v of 4, and it was negative. And notice, actually, all you have to do is say it's less than 0. You don't even have to list that value there. By the way, I must have typed my derivative in wrong because I got negative 99. I must have typed the equation in wrong. But notice, they say that A is just really the acceleration's the derivative of the velocity function. And again, it's less than 0. And the key here, the speed is increasing. Okay, it's speeding up because velocity and acceleration have the same sign. That's all they say to explain that. And so if you got that right, you would get, I'd probably only get 1 out of the 2 since I got that. My acceleration was wrong, but my conclusion based on the data was correct. So I think we would have gotten 8 out of 9 on that one. So that's a good overview of a pretty nice example of a motion problem.